All right, so on question 9, we have glycerol and nitric acid produce nitroglycerin. So you've got C3H8O plus nitric acid. And you're given the formula of nitroglycerin earlier. That is C3H3 C3H5 N3O9 plus H2O. So if you look at some clues here, you know you're going to need 3 nitrogens. And that gives us 11 hydrogens. So we need 6 right here. That's 12 oxygens. 3 and 9. Oh, I miswrote that. This already has 3. That's perfect. So there's our stoichiometry, and we want to convert 1 mole of glycerol. We need to know how much nitric acid we need. So we could start with 1 mole of C3H8O3. And we know that 1 mole of this reacts with 3 moles of nitric acid, and that 1 mole of nitric acid is 63 grams. So that's going to be 189 grams of nitric acid that's needed. Closest answer is D. And then number 10.
This is just a stupid mistake.
Well, you know the reaction's spontaneous, so you know it's negative delta G. And you know that it produces, well, let's see, 22, 28, 29 moles of gas from 0 moles of gas, positive delta S. And that's consistent with D as well. And then number 12. 12 is a good question because we want to know what's going to maximize the pressure. So if we look at ideal gas law, PV equals nRT. Pressure is directly proportional to the number of moles. And if we look at our answer choices, we're going to have the same mass of each of these substances. So we have CO2, we have H2O, we have N2, we have O2. And so whichever one gives us the most moles, which is going to be the one that has the smallest molar mass. So this will be 25 over 44, 25 over 18, 25 over 28, and 25 over 32. Water's the best. More moles, greater the pressure. All right, so moving on to number 14. All right, this is an example of one I do not want you to miss ever. Magnesium is 1s2, 2s2, 2p6, 3s2. If you ever have any questions about that, just look at the periodic table. So you've got hydrogen, and on the other side you have helium. And you have lithium. On the other side you're going to have neon. So here's your 1s2, your 2s2, your 2p6, sodium, and then magnesium. Here's your 3s2. If you're going to make magnesium 2+, you remove the 2 highest energy electrons, which means you knock these out. So you're losing electrons from the s orbital, which is where L equals 0. L equals 0 is the best answer.
this one's just...
All right, so elasticity of solids give people a lot of problems. How many did you miss in this one?
1, 2, 3.
Okay. That's actually not horrible.
Well, this one is the worst because I put that and then psyched myself out and convinced myself that one was right.
So just remember this. F equals minus K delta X. This is called Hooke's law. Very analogous to this because stress equals a constant, which we call Young's modulus, times strain. So this is F over A, which you see in the passage, equals a constant times delta L over the original length. So you can see that this is analogous to delta X. That this is analogous, pressure is analogous to force, constant is analogous to constant. So it's really Hooke's law. And so if I graph stress as a function of strain, it is the same as y equals mx. B is 0, so it goes through the origin, and it's directly proportional, which means straight line. Well, that's not much of a straight line, but you understand what I'm saying. It's as straight as fly. And that's answer choice B. Best answer by far. What's the next one? Everybody misses this problem. And honestly, this is what leads me to believe that this test is really not a former MCAT. I think that AAMC is in bed with Princeton Review because Princeton Review did this exact problem on a test in 1988. And yeah, I remember it.
Dang.
Fucking assholes. Alright, so here's how we're going to do this. You've got F over A equals E delta L over L naught. We want mass. Force is equal to mg, right? Which is equal to E A delta L over L naught. Mass equals E A delta L over L naught, and all of that is divided by G. Alright. We're given Young's modulus as 2 times 10 to the 8th newtons per meter squared. By the way, this unit, newtons per meter squared. Newton is a unit of force. Meter squared is a unit of area. A newton per meter squared is force per unit area, which is pressure. That comes in handy later in the passage. Okay, now it gives us the area in terms of centimeters, square centimeters. When we convert that to square meters, that's 5 times 10 to the minus 4 square meters. And we need that so these cancel. And finally, the delta L over L naught is 1%. We're just going to call that 10 to the minus 2. And all of this is over G, which is 10 newtons per kilogram. So our newtons cancel as well. And our unit will be a kilogram. So we simplify all this. 2 times 5 is 10. and 10 divided by 10 is 1, so I'm just going to cross all that crap out. Then I get 10 to the 8th times 10 to the minus 6. That is 10 to the 2 kilograms. 100 kilograms is the answer, and that is A. Everybody misses that question.
I'm not surprised. Why is the G in the denominator in newtons per kilogram?
To get the Newton units to cancel, every time I have a kilogram, it's 10 newtons, or 9.8 meters per second squared. So a Newton per kilogram, remember, a Newton is a kilogram meter per second squared. Over a kilogram, it's just a clever way of doing the units. So it's a meter per second squared, which is a unit of acceleration.
Okay, cool.
Which is what G is. So 23 has nothing to do with the passage whatsoever.
Lenses.
All right, we are given the formula for power in diopters is 1 over F. But F is the focal length. And the focal length must be converted to meters. And we are given that the focal length is 2 centimeters. That's 2 times 10 to the minus 2 meters. So 1 over 2 times 10 to the minus 2 meters is equal to 0.5 times 10 to the 2 inverse meters, which is a diopter. 50. I don't like this because 40 is the best answer because it's closest. The answer choices should be better than that.
Yeah.
But D is the one you have to pick. It's the best answer. It's the least full of shit. Yeah, so this passage is not very MCATable. So I'm talking about passage 4. So passage 4 is all about terminal velocity. I know I'm making it look like this is easy to write on. This shit's harder than hell, dude. You should have seen it when I first started doing it. Okay, so why can you ignore air resistance when a compact object falls a short distance? I mean, the longer it's in the air, the greater the speed is going to be. So you can ignore air resistance when the speed of the object isn't too great. So we can ignore the force of air resistance when distance traveled results in a small velocity. So you can effectively ignore it. Now, if we look at problem 27, you have an object with mass m that falls a height h. It's falling straight down vertically. It achieves a terminal speed vt. Which the following expressions represents the power exerted by the force. So power is work divided by time. Work can be force times distance divided by time. Distance over time is acceleration. Or excuse me, not acceleration, it's velocity. What's the force? It's going to be mg. What's the velocity? It's the terminal velocity. Now, Fortunately, they don't
Give the positive and negative.
they don't give the positive and the negative, but essentially this thing's going to start at 0, and you could, when you get this, you choose the up to be positive and the down to be negative, but this is enough for you to distinguish between the answer choices, which is going to be A. This gives people problems as well.
A lot of it seems to just be unit conversion.
A lot of it is unit conversion. A lot of it is just having a really good grasp on conceptual physics, which a lot of people are good at doing math, but you have to know more than that for the test, for the MCAT, because a lot of these questions are going to be conceptual. So, relationship between distance, fallen, and time. Alright, now let's look at the graphs carefully. So A, distance versus time. B, distance versus time. C, distance versus time. And D, distance versus time. 2 of these can be eliminated right off the bat. So both, let me just label these, A, B, C, and D. Anytime I get a graphical question, I'm automatically looking to get rid of the bullshit, to condense the nonsense. Both C and D insinuate that there's some time at which the distance will no longer increase. Now think about that conceptually. That means an object is in free fall and all of a sudden it stops falling. So is it hitting the ground? That certainly is not insinuated in the question. So, boy, I would love to do this with some people at Southwest, just to throw them off like a skyscraper and see if they levitate or if they just smash. So C and D are pretty stupid. So let's get rid of those. A means that the distance traveled is always directly proportional to time, and that's stupid as well. Because when the object first starts to fall, it's experiencing gravity and not a lot of air resistance, which means the distance versus time should be a quadratic, not a line. For example, D equals VOT plus 1/2 AT squared. This is a quadratic equation. It can't be A. B makes the most sense. In the beginning it's quadratic, but once the force of air resistance is equal to the force of gravity and you reach your terminal velocity, now your distance changes linearly. So it has a line component and it has a quadratic component. So this is before air resistance balances out gravity, and then in orange is after it balances out gravity. B is the best answer. Conceptually, that's what makes the most sense. This shit tore you up, didn't it?
Yeah, it did.
Nice. Okay. How much gravitational potential energy is transformed? Okay, well, we know gravitational potential energy is equal to mgh. And we know that h is 2 times 10 to the third meters. What is our mass?
75 kilograms.
75 kilograms. And of course, G is going to be 10 newtons per kilogram. Now, a newton meter is a joule. So the units are going to be joules, which means I can just multiply all this stuff together. So 2 times 10 to the third meters times 75 kilograms times 10 newtons per kilogram. Kilograms cancel. And I'm going to have 2 times 75 is 150. 150 times 10 is 1500. I know my mantissa is going to be 1.5. I'm going to stop right here. It cannot be B and it cannot be C. So what I'm going to do now is this is 7.5. Well, actually, let's do this. Let's do 0.75 times 10 to the 2. This is 10 to the 1. This is 2 times 10 to the third. This is my 1.5, and of course I add all my exponents. That's 10 to the 6th joules. We're done. Now it's D. I never complete the math until I know I have to. I always do a little piece and I see what I can eliminate. When I took my MCATs way back in the day, I used to always do the problem all the way through. And so, like the first time I took an MCAT, my physical science score was a 7. And then the second time I took it, it was an 8. And then the third time I took it, it was a 9. And I was like, this is stupid. Then I started doing what I teach people to do. And the fourth time I took it, I got an 11, and I swear I maybe guessed on 3 questions. Should have been even higher than that. So doing it this way now is how you get a score like this. Content gets you scores like this, and that doesn't distinguish you at all. You know, really, if you want to go, I guess you're wanting to go to UT?
Yeah.
Okay, I guess small goals are fine.
I'm applying to a lot more than that.
I'd definitely go to UAB over UT.
Yeah.
And I work for UT every summer for MCAT. I would tell you that you're too smart to go there. 11-11-11 gives you an opportunity to compete for scholarships so that you get some tuition remission. So someone as smart as you, we shouldn't just be trying to get you into school. We should be trying to save you tens of thousands of dollars, which after you pay off your student loan, I mean, you could save as much as $100,000. That is a really nice car. Or to keep you a bitch on the side too. I mean, whatever you're into, man. I'm not here to judge.
It's just like cars.
Yeah. Okay, so we're done with that one. Let's go to the next one. Oh, we got one left, don't we?
Yeah, just 30.
What's the magnitude of air resistance? When the velocity is equal to the terminal velocity. It is equal to the terminal velocity because the force of gravity, mg, is exactly balanced by the force of air resistance. Okay? So what that means is we know that this is 750 newtons. This must be 750 newtons because when it's less than 750 newtons, this accelerates in the down direction. Once this is invoked, that's when you reach the terminal velocity until the object hits whatever object it's going to hit. In the case of dude whose parachute doesn't open, he's going to black out and not feel himself crush into a billion pieces, but he won't accelerate anymore once this is invoked.
Okay. That's an easy one.
That's what terminal velocity means. All right. So, molar solubility, this is very useful when you have a double displacement precipitation reaction and you're trying to determine what your precipitate is going to be. So in the problem, we have a solution of magnesium sulfate. Now remember, this is a solution, so it's aqueous. So I don't give a rat's ass what its solubility is, because I know it's soluble. And we also have nickel fluoride. And again, nickel fluoride is soluble. So I don't give a rat's ass about its solubility. If I propose a double displacement reaction, nickel sulfate, I do care about that one. And magnesium fluoride, I do care about that one. So I need to know the KSP of nickel sulfate. I need to know the KSP of magnesium fluoride. So let's look at our answer choices, A, B, C, and D. And we're looking for the thing that is least useful. So we have the molar solubility of magnesium fluoride. We definitely want to know what that is, because if we know the molar solubility, I can calculate the KSP and determine which of these two is going to precipitate. By the way, it's going to be this guy. Sulfates are notoriously insoluble. We have the molar solubility of a reactant. I don't need that. We have the molar solubility of our other product. And we have the concentration of a reactant. Now that's important, because that concentration of that reactant is going to help us determine if I've got enough in solution, exactly enough in solution, or too much in the solution. So when I'm eliminating choices, I need to know A and C and D, but I do not need to know B. B is clearly the best answer. This one gets a lot of people too. Okay. So we have 2SO2 plus O2 yields 2SO3. And I'm given thermodynamic data, delta H is minus 197.8. I already know this is exothermic from the sign of delta H. Is it reasonable to, and look at that, before I even look at the question, I first know the answer is no, which allows me to eliminate C and D. By the way, we're eliminating something that you just picked.
Yeah.
Now, A tells us everything we need to know, right?
Yep. That's just a test of.
B is just completely irrelevant. So A is what we want to pick.
Okay.
When we are test ready, you will not miss questions like the last two we just did. You're rusty right now. That shouldn't be all that surprising. All right. Most ionic compounds with strong ionic bonding. Well, one is definitely true. They will have higher melting points. So again, once I figure something out, let's look at the answer choices. 1 only, 2 only, 1 and 3, 2 and 3. So once I know that 1 is correct, I want it to be part of my answer. Look what happened again. I immediately eliminated one that you picked. Now, what's left is A and C. Should I even read statement 2? Absolutely not. It's not
relevant.
It's not relevant to getting it right. Electrical conductance when dissolved in water. Definitely. Definitely. So that means that 1 and 3 is the best answer. I pick C. never evaluate more than you need to answer a question, because that's when stupid things happen. Okay, so now we have an electrochemical passage. These are Mcat favorites. They're also some of my favorites as well. So they are giving us data in number 38. So let's look at this holistically for a moment. So we got this beaker and a solution. We have an electrode. And so they refer to this as a solid metal, and they refer to this solution as Ym plus. We don't know if it's +1, +2, or whatever. So if a reaction occurs, that means that X will be oxidized to Xm plus. And it means that Ym plus will be reduced to Y metal. And then we're given a bunch of tabular data. And so I want to focus on this first row. So we have Al 3 plus in a row, and then in columns we have aluminum metal, we have copper metal, we have zinc metal, we have silver metal, we have gold metal. Got that from someone's Toofies in South Montfort. And we have lead metal. Now obviously there's going to be a reaction here. But look at copper. There's no change. That means that is not a reaction. With zinc, there is no change. That means there's no reaction. In fact, there's no change with any of these. Which means aluminum 3 plus is not easily reduced. If, however, we look at copper 2 plus with aluminum metal, we get a new solid. What this means is that aluminum can be oxidized to aluminum 3 plus, and copper 2 plus can be reduced to copper solid. So rather than give you electrical potentials, they give you kind of a chart you might make in a general chemistry lab. All right. So now let's look at the questions. Number 38. All right. So we're asked to make an assumption. Now we already know that aluminum has to be oxidized to Al3 plus. And I'm just going to balance it with electrons. And we know that copper 2 plus can be reduced to copper, and that takes 2 electrons. And this is based upon our data, because aluminum 3 plus does not react with copper, but copper 2 plus reacts with aluminum metal. And now all I need is for it to be properly balanced. For it to be properly balanced, I need 2 of these guys. I need 3 of these guys. So it should be 2Al plus 3Cu2 plus yields 2Al 3 plus plus 3Cu. That's C. Now, a couple of these you can eliminate right off the bat.
The imbalanced ones.
Imbalanced charge, eliminate right off the bat. Imbalanced charge, eliminate right off the bat. Why is this eliminated? Not consistent with the data. Best answer is B.
Okay.
If I had to be a betting man, I would bet that the chance you see an electrochem passage on your test is really, really good. Okay, so now we have a lead to lead 2 plus. And we have a Cu 2 plus to Cu. Now let's look at the data again. So if you scroll up to the table, lead 2 plus and copper, no change, right?
Mm-hmm.
So, but it says X is Pb. Now if we go back and look at our picture, if X is Pb, then this must be oxidized to Pb2 plus, and copper 2 plus must be reduced. So copper with lead, 2 plus nothing, but copper 2 plus with lead gives us a new solid. So first of all, the answer is yes. That allows us to get rid of A and B. And of course, the electrical potential, if the answer is yes, the electrical potential must be positive. The number's irrelevant for every, it doesn't matter. Because you can do that from the data. Now, they may give us data at the bottom as well, but that just is another way of doing it. And they do. Look at that. So when this is reduced and this is reduced, so we can make this oxidize. We turn that around, we flip the sign, and that's where we get the plus 4.466. But you don't need this to answer the question.
Okay. I think there's another one.
Yeah, so what do we know about the passage? We know that the light bulb has a resistance of 0.5 ohms, and there's a voltage of 2 volts. V equals IR.
Oh my gosh, I knew that and I still messed it up.
I equals V over R. That's 2 over 1/2.
4.
I is 4 amps. Remember, a volt is a joule per coulomb. And what is the, I know we call it an ohm. Current is a coulomb per second.
Mm-hmm.
Wow, that's a hell of a unit for resistance. A joule second over coulomb squared. Plug and chug, it's 4.
Okay.
Yeah, so this optics passage, look, you need to stop the angle at pi over 2 because that's when you'll be perpendicular. You don't want the angle to be any larger than that. That's a very common constraint too in physics. If it goes to 3 pi over 4, dude's car's going to be inverted and his ass is going to be thrown from it.
Okay.
Technically, that's frowned upon in a ride. Yeah. They're frowned upon that.
There's some leeway.
So, in this last one, this is all about fluid. So you got continuity equation, that's important. You know that A1, V1 equals A2, V2. We also know that if we want to find the mass of something, we can take the density times the volume. And that's what we're going to do here. So we want gravitational potential energy. So we want mgh. What are we given? We're given the h, that's 0.2 meters. Of course, we know what g is, it's 10. And it's going to be 10 newtons per kilogram. Again, this is going to give me a Newton meter. Now, what about mass? we know the volume of water. So 4 times 10 to the minus 4 cubic meters. The density of water to a physicist is 10 to the third kilograms per cubic meter. To a chemist, it's a gram per cubic centimeter, or a gram per mil, exactly. And then we're going to multiply that by 10 newtons. There's some weird ass people coming to this library, dude. I'm telling
It's
you.
good people watching.
There's some guys with snatcher vans here. I just know it. I just know
I
it.
took this in the Carnival Library, and it was really difficult. Like, it's pretty distracting.
I got some freakoids over there too. So it's a Newton meter. Now we've got 4, we've got 40, we've got 8. 40, yeah, we've got 8. And let's see. I'm missing something. Is it 4 times 10 to the minus 4? Yeah.
So would it be 8, 10 to the minus 1?
Yes. 0.8 times 10 to the 0.
Oh, okay.
0.8 joules. And that is B. Okay, now we're told that the mass of the tank is 9,500 newtons when it's empty. So gotta have some multiple of 9,500 so you can get rid of A. And it holds 10 cubic meters. So you got 10 cubic meters and a density of 10 to the third kilograms per cubic meter. That's 10 to the fourth kilograms. You multiply that by 10. Meter per second squared. So that gives you 10 to the fifth newtons. That's 100,000. So we're looking at 109,500, and that ends up being C.
I don't know why they highlighted both of those.
Because they're stupid.
Might as well.
Okay, simple definition for this one. Ionization energy means the energy required to remove an electron. It is always endothermic, so energy must be a reactant. Stop. Get rid of C.
Mm-hmm.
Also, you can get rid of B.
Because it's,
All you're doing is giving it a positive charge. You're not breaking a covalent bond.
Okay.
And you're ejecting an electron. That's D. So you chose the one where you broke a bond. That's called a homolytic bond association. Or actually, heterolytic bond association.
It's heterolytic?
Mm-hmm.
Why
Because
is
you get 2 charges.
Oh.
If it was homolytic, you get 2 radicals.
Okay.
Yep. Calcium is a charge of +2. Oxide's a charge of -2. They combine 1 to 1. MO.
Oh.
Right.
Yep.
Okay, so we'll stop this one for now.
Okay. What's